Okay, so now we officially start series, and now we can officially add stuff together. So we call this first set of examples geometric series. You can call them exponential, and there's different words, but this is the gist of what we're talking about. I want you to think about this. What happens if I do the following? The simplest example is 0.33333. This may be the first geometric series you ever encountered, and you didn't know you were encountering it, and your teacher told you that's equal to a third. Well, how do you know that's equal to a third? Well, let's talk about that. Here's officially what you're going to do. You're going to say 10 times s equals 3.3333. Then you're going to say 10s minus s is 9s is equal to 3. So s must equal 3/9 or 1/3. This is exactly what you would do to convince a middle school or elementary school child that this sums up to 1/3. And that would be the end of it. And that's all we're going to do. It's really not any more complicated than that. It's just going to look more complicated than that. Let's do the same thing and use a fraction instead of a decimal. What if you have 4 plus 2 plus 1 plus 1/2 and so on and so forth? What does that add up to? Well, if you've been paying attention, it's just going to be 4 plus 2 plus 1 plus 1. But maybe you're not really paying attention. Whatever. What you want to do is look and see what the ratio is between these two values, or if your preference is to multiply instead of divide, go the other way. Okay, that's fine. The ratio is 2, or 1/2, depending on which direction you're going. So if I multiply this whole thing by 2 or 1/2, either direction, I'm going to get something that comes out to be useful to me. Right, so I can say 2s is 8 plus 4 plus 2 plus 1 plus 1/2. Well, now I can take 2s minus s and get s, and all these terms wipe out except for the 8, and there you go, and you're done. So wasn't that hard, was it? See, I told you it was easy. Okay, so let's generalize this. What if we have a series that starts out with some value, okay, and you want r to be between 0 and 1, or this isn't going to work. We really don't want, well, you can flip-flop, but we can talk about that later. You can make it negative, but right now let's assume it's positive, and let's assume that these things are going to shrink down. So like these terms of the series are going to shrink down. Then we can do this sort of thing. All right, and we go ahead and solve for s. Okay, well, I'm going to multiply either by r or 1 over r, whichever one I prefer. It doesn't much matter as long as what you get can be easily subtractable, so we can end up with pieces we like. Okay, and so now I'm going to go like rs minus s equals what? So all this stuff cancels out, right? And then I'm going to just get a. I'm going to factor out the s, and I'm going to get s is equal to a over r minus 1. Well, r is going to be between 0 and 1, so this is a bit of a problem, right? Except I made a clerical mistake, so hopefully you caught it. This should have been minus a because I said this guy minus this guy, right? So I did it in a funny way. So actually it's just a over 1 minus r, and so sorry about that typo, or that like algebra mistake, I guess. Okay, but what if we don't want to actually go off to infinity? We just want to stop at a r to some capital N. Sometimes we need to do that. So the same thing works, you just end up with another little piece. So you can just go s times r equals, and then you still multiply by r, but then you have to be careful about where you end up. You still end up with AR to the n, but you just multiplied everything by r, so you get one more piece right here. And then when you do the subtraction, so this time I'm going to subtract it in the correct order for you. Okay, so these pieces all match and these pieces all match, but there's a leftover piece. You get a minus a times r to the n minus n plus 1, so you get 1 minus r to the n plus 1, and then so you get s 1 minus r equals, you just really love to see me do this, right? And so s is a 1 minus r to the n minus 1 all over 1 minus r. And that is the extent of what we're doing. All of our examples basically boil down to that. Okay, now there's a couple different ways you can deal with alternating signs. I'm just going to cheat. I'm just going to multiply by r squared and pretend like there is no negative sign. You could do that, or you could actually deal with the signs. I don't really care. Let me make one up for you. Okay, I'm going to make this start at 1, and I'm going to multiply by 1/4, or if you think about it, multiplying by negative 1/4 every hop. And then if I am just really lazy and don't want to deal with signs, I can just kind of pretend like this piece is a certain piece, and I'm just going to deal with it as 1 minus 1/4 is 3/4, and I'm going to just say, fine, I'm going to just multiply by 1/16. That's just my choice, okay? You can do this other ways. That I'm going to write 1/16 of s is 1/16 minus 1/64 plus 1 over 256 minus 1 over 512, blah, blah, blah. Okay? And now you can see that since we're dealing with infinity, all this stuff is going to be equal to all that stuff. And now I'm going to just say s minus 1/16 of s is equal to 1 minus 1/4. So 15 over 16 of s is 3 over 4, and then you can solve from there, no problem. And I'm just doing this with numbers, but you can do this just as easily with letters. It's totally fine. But what if you say, hey, I don't feel like multiplying by 16? Fine, be my guest. Multiply by 1/4, see if I care. So now what do I get? I get 1/4 minus 1/16 plus 1 over 64 minus 1 over 256. Then I can add these guys together, and I get 5/4 s equals to 1, I guess. Anyway, no harm done. You should get the same answer. Math shouldn't be broken, and you should just be fine and go about your life. That should work. So I guess s should be 4/5. So I guess the only thing I want to talk about is web work. And that's this question. They're going to probably give you a series, and ask you if it's a geometric series or not. And so if you want to determine if a series is geometric, according to web work, it's going to have to be very strict. It's going to have exactly this format. So to me, if I had an extra couple things tacked on the end, like a 7 and an 8 and a 4, and then I went into this 1/2, 1/4, 1/8 business, I would say, okay, it's geometric from there on down, it's good enough. And I would call it geometric. I don't think they allow that. I think they're saying it's not because there's some garbage at the front end of it that makes it violate the rules. Okay, so just be careful with those exercises and definitions. So just as a mathematician, I'm used to stripping off the first however many terms I don't like and then going downstream. But I do not believe web work allows you to do that for this exercise. Okay. Okay, so just let me know if you have any trouble. I think this should have been pretty straightforward for most people. And question 4 is more fun than the other ones. Have fun with that, and I'll see you on the flip side.